Let's continue our discussion on lines and angles. So consider two lines L and M. If those two lines don't have any point in common, they are called parallel lines. Whereas if two lines, in this case P and Q, have a point in common, these are called intersecting lines. Two intersecting lines will always have only one intersection point. As you can observe here, these two lines cannot intersect at any other place. And they form four angles as seen here. So if you observe closely, angle 1 and angle 4 have the same vertex and a common arm. So these are adjacent angles. Similarly, angle 1 and angle 2, angle 2 and angle 3, angle 3 and angle 4 are all adjacent angles. Whereas angle 1 and angle 3 and angle 2 and angle 4, if you observe, they have the same vertex but they don't have any common arm. These are called vertically opposite angles. Vertically opposite angles are always equal. So in this figure, as you observe, what we are saying is angle 1 is equal to angle 3 and angle 2 is equal to angle 4. So let's try to prove this theorem. So the theorem states that if two lines intersect each other, then the vertically opposite angles formed are equal. So let's consider the case where we have to prove angle 1 is equal to angle 3. We know that angle 1 plus angle 4 is equal to 180 degrees based on the linear pair axiom. Similarly, angle 3 plus angle 4 is also equal to 180 degrees based on the same linear pair axiom, which is if a ray is standing on a straight line, then the sum of the adjacent angles formed is always equal to 180 degrees. So we have these two statements. So we can say angle 1 plus angle 4 is equal to angle 3 plus angle 4. So angle 4 cancels out, and what you are saying is angle 1 equal to angle 3. Similarly, you can also do the proof for angle 2 equal to angle 4. Now let's work on a problem. In this figure, you have been given that x is to y is to z is equal to 2 is to 3 is to 5, and you are asked to find the angles x, y and z. So let's try to solve this. As you can see in the figure, angle EOD, which is x, is equal to angle AOB because these are vertically opposite angles as they have the same vertex O and no common arm. So angle AOB is also x. So now consider the line CF and the ray OA. So a ray OA is standing on the line CF. So which means that the sum of the adjacent angles formed by the ray is equal to 180 degrees. So what you are saying here is angle AOF plus angle AOC is equal to 180 degrees. But angle AOF is y and AOC is nothing but x plus z, which is 180 degrees. So now we have got the first equation, which is x plus y plus z equal to 180 degrees. But you are also been given x is to y is to z is 2 is to 3 is to 5. So what that means is x by y is equal to 2 by 3, y by z is equal to 3 by 5, and x by z is equal to 2 by 5. So we have x plus y plus z equal to 180 degrees. That's our first equation. Then from the ratios given, we know that x by y is 2 by 3, which means y is 3 by 2 times x. That's our second equation. Y by z is equal to 3 by 5, and finally x by z is equal to 2 by 5, which means z equal to 5 by 2 times x. So this will be our third equation. Substituting 2 and 3 in 1, we will end up with x plus 3 by 2 times x plus 5 by 2 times x is equal to 180 degrees, which is nothing but this is x plus, taking LCM out, you will have 2x plus 3x plus 5x is equal to 360, because you will take the denominator 2 and multiply it on the right hand side. You'll have 360, which is nothing but, if you observe, 10x is equal to 360 degrees. So x is 36 degrees, which means y is equal to 3 by 2 times 36, which is 54. And finally, z is equal to 5 by 2 times 36, 2 times 18, 18 5 90. X is equal to 36 degrees. Angle y is equal to 54 degrees, and angle z is equal to 90 degrees. And if you take the ratio of these three different angles, you'll have 18 2s are, 18 3s are, and 18 5s are. So 2:3:5, which is given in the problem.